The system of money has been used for millenniums in trade and commerce. It is based on an understanding that common items, such as coins, have an equal value to everyone, and all transactions can be described as an exchange of property for a monetary value. The minimum value of currency quantizes exchanges, such that small fractions are not considered. In Australia, where the smallest coin is a 5-cent piece, the final total for items, with values which may be described in cents, is rounded up or down to complete the transaction.
The most common shape for a coin is a circle, but other polygons are sometimes used, like the 12-sided Australian 50-cent piece. Circular coins may have grooves in the edges called graining. Given enough time or mechanical abuse, this graining will wear away. To create a circle the same size as a coin, ink could be applied to the circumference of the circle, providing that the paper does not absorb too much ink, thus underestimating the size of the circle. The center of the circle can then be found by two chords of the circle, bisected with a line drawn from the center of each chord, intersecting at the center of the circle. A pair of compasses may also be used, with the distance from the sharp point to the pen tip being the radius of that circle. Assuming that the dimensions of a common coin is always similar, you can find the length or thickness of a coin by finding the length or thickness of many coins and then dividing by the number of coins. This effectively averages the dimensions of the coins. Mass for one coin is averaged by weighing many coins and dividing by the number of coins. The mass of an individual coin can be found in a similar way using calibrated weighing equipment. The length of a coin can also be found by throwing the coin onto ruled lines of different widths, and the probability that the coin lands on a line and the width apart of those lines are then used to calculate its length. I started collecting 5-cent and 10-cent pieces at the start of the year. 9 months later, I have 151 5-cents and 167 10-cent pieces. They are distributed according to year that they were produced. I rated how corroded each of them looked and tried to determine how much age had affected them. The sample size is not large enough to suggest the percentage of coins of each individual year currently in circulation, but it appears that most of the coins are very recent. Perhaps older coins are lost or are removed from circulation when they have degraded significantly. The face of Australia's monarch on the reverse of the coins is different depending on the time it was printed. From 1966 to 1985, a young Queen Elizabeth II with her shoulders is featured. The image was changed once again in 1999. The most recent coins just depict her head. The changes to the date of the coin and any corrosion or mechanical misadventure will also have an effect, positively or negatively, on the weight of the coin. The weight on one side of the coin might be enough to change the center of gravity of the coin, affecting the amount of times the coins land on a particular side when flipped. The three landing positions for a coin are upon its obverse, reverse, and the side. In practice, it seems that a coin is easier to balance on its side if it retains a graining. Although there is some slight difference between weight between these coins, an average value for their weight will allow other items to be measured in terms of the weight of that coin. A balance is constructed that will balance wherever equal weights are placed inside the pans. Mathematical equations are used to represent this balance phenomenon. Whenever one side of the scales is level with the other side of the scales, one side is equal to the other with respect to weight. When a ruler is used to measure lengths, that property may be equal to the other when both lengths are equal, at the same level. The scales are constructed such that the weight of one side acts against the weight of the other side. The side with a heavier weight will unbalance the scales and eventually that side will fall. To keep an equation in balance, it should be noted that performing the same action to both sides of the scales will keep them in balance. Removing, adding, multiplying, dividing, all result in the same weights being applied to either side of the scales. In this way, a coin with an unknown weight can be determined based on the ratio of numbers of the unknown coin to the numbers of coins with a known weight. My balance made from a soup can was not strong enough to support the weight of particularly many coins.
Individual atoms might also be represented by coins. Even though it is not quite an accurate representation, if a 20-cent piece represents the weight of an oxygen atom, and a 5-cent piece represents the weight of a hydrogen atom, then a water molecule can be represented by 2 5-cents and 1 20-cent piece. In any chemical reaction, the same types and numbers of coins must appear on both sides of the scales to balance the equation. This is a concept known as conservation of mass. Coins may also be used to measure the weight of any substance, such that the weight of that substance is an integer multiple of the average weight of the coin.
I created a 0.05 moles per litre solution of copper sulfate for an electroplating experiment in which I intended to add copper to one coin-shaped piece of metal and remove copper from the other. I used some fingernail polish to mask areas that I did not wish to be altered and connected electricity to both the coin and the other electrode. I connected a mobile phone charger power pack through a diode and a potentiometer to control the process. When the voltage across the system was too high, a black furry substance appeared on the coin. When the voltage was within a certain limit, a pink substance appeared on the coin, but a large coating didn't occur. Perhaps the system required the coin to be cleaner, a greater concentration of copper sulfate, or a smaller distance between the anode and cathode. I wasn't able to use more than one of the 12 stencils I had constructed for a three-dimensional version of my head. These stencils were created by scanning my head with 2 planes of light restricted by a cardboard blind and the use of some computer graphics editing software. Coins are normally made by a process of compressing metal with dies, similar to a hammer hitting a punch. This requires that the die is made from a harder material than the metal that it is required to compress when impacted.
Coins have properties that determine their value, and they also act as a standard for measuring transactions. They are a physical reminder that an exchange has taken place, and are also valued for rarity and beauty of certain coins. Coins can also be used as analogies for other processes based on their physical characteristics such as length, weight, and conductivity. The fact that most coins are similar in many cases is their strength, but an individual coin can also have value depending on how much demand there is for the coin that has the ideal inherent properties.